All right, so I'm just going to take a minute and go over this homework assignment, and if you have any questions, please reach out. All right, so 10 to the 5th would just mean you're multiplying 10 5 times, so you're actually going to just have a 1 with 1, 2, 3, 4, 5 zeros, okay? 9 to the 4th would mean 9 times 9 times 9 times 9, and then 9 to the 4th would give you a total of 6,561. Okay, all right, 3 to the 3rd times 3 to the 2nd, you know you have the same base, so keep the base, and since you're multiplying, you're going to add your exponents, okay? So 3 plus 2 is going to give me a total of 3 to the 5th, and you can simplify that out to get 243. Okay, 4 to the 4th times 4 to the 2nd, keep the base the same. You're going to add your exponents, so 4 plus 2 gives you 4 to the 6th. Multiply that out, and that is going to give you 4,096. Okay, now you're not necessarily, you wouldn't have to multiply that far out without using a calculator, okay? Like I said, also you can think of this as 4 4s and 2 4s, so if you're having trouble understanding that, it's 1, 2, 3, 4 4s, and then you have 2 more for a total of 4 to the 6th. Okay. All right. So you have two bases that are the same, x and x. So you're going to add your exponents. So this becomes x to the 15th. Okay. This one right here, you actually have two pieces here. So we have x squared raised to the 2nd. So you're going to multiply these two exponents to get this to be x to the 4th. This one has nothing outside the parentheses, so we can just drop the parentheses. Now, since I have two bases that are the same and I'm multiplying them, I can add the exponents to get x to the 7th. Okay. All right. Now this one right here, you don't have any exponents outside of your parentheses, so you don't have to raise anything to a power here. So all we're kind of like adding, we're combining like terms sort of. So here we can do 9 times 5 to give us 45. Okay. We have a to the 3rd and a to the 2nd. So I could just completely get rid of these parentheses and just put a multiplication sign in here. They're not doing anything here other than separating. So if I have a to the 3rd times a to the 2nd, I can just add those two exponents to get a to the 5th, okay? And then you have b to the 4th times b to the 2nd. So I can just add those two exponents to get b to the 6th. And then the c is just chilling by itself. There is nothing that is like c, so it's just going to come along for the ride, okay? All right, so this next one here, we have the 3 outside the parentheses. Now we have two bases, a 4 and an x. There's no exponent, so the understood exponent is 1. So that 3 has to get multiplied to both of those bases. So this becomes 4 to the 3rd times x to the 3rd, and make sure you simplify 4 to the 3rd is 64, because you can do that without a calculator. 4 times 4 is 16. 16 times 4 is 64, x to the 3rd. All right, this one right here, we have two bases raised to a power, so I need to multiply that power to each exponent on each different base. So I have 10 times 5, which is 50, 2 times 10, which is 20, okay? This one right here, we have multiple bases raised to an exponent, so that 2 has to go to every single solitary base. So the 4 doesn't have an exponent, but it's an understood 1. It's not there, but it's still a base, so we can't forget about it. So this becomes 4, 1 times 2 to the 2nd. 6 times 2 is n to the 12th. 2 times 2 for your m, which is going to be 4. All right, so number 11 right here, we have two bases that are the same. We're dividing. So what we're going to do is we have to subtract our exponents. So we have 10 to the 11 minus 6, which makes this 10 to the 5th. Right here, we have the same bases and we're dividing. So we're subtracting our exponents. So 3 minus 2 gives me 4 to the 1st. Okay, so this one right here, you have two bases that are the same, so you're going to subtract your exponents. So you have 42 minus 39 makes that 11 to the 3rd. Okay, and I would not make you multiply that one out. Okay, 5 to the 2nd over 5 to the 3rd. So you keep the base the same, subtract your exponents, makes that 5 to the 4th, okay? Once again, I wouldn't make you multiply that out. You can do 5 times 5, which is 25, times 5, which is 125, but that's probably about the highest you'd have to go. All right, so right here you have 8 over 4, so let's simplify that to 2. Then you have r to the 5th over r to the 3rd. We're going to subtract those exponents to make this r to the 2nd, okay? Now, -2, this does not have a negative exponent, so that is totally fine the way it is. So first we're going to simplify this, and this becomes -1/2, okay? And then you have a to the 5th over a to the 2nd, so we're going to subtract 5 minus 2 to give me a to the 3rd. Just to write that a little bit prettier, I don't need to write -1 times a to the 3rd, so that's just -a to the 3rd all over 2, okay? All right, so we have two bases that are the same, x and x, so 4 minus 3 becomes 1x on the top, okay? Y and y are the same, 3 minus 2 becomes y on the top, and there's actually nothing left on the bottom, so this is just xy. All right, this one right here, we have a division problem raised to a power, so this exponent of 2 must go to every single solitary base inside of your set of parentheses. So 10 to the squared, so 2 times 2 makes this 10 to the 4th, all over y, 3 times 2 is 6. Now you could simplify this, the 10s are easy, it's just 4 zeros, all over y to the 6th. You can handle that one. All right, now this one right here, what we're gonna do is let's just multiply straight across the top, straight across the bottom, and then simplify from there just to make it a little bit easier. Okay, so 4 times 5 makes that 20. Okay, and then x to the 3rd and x to the 3rd we're adding. So that's x to the 6th, y times y is y to the 2nd, all over 10 x squared y to the 3rd. Now that we have one piece, now let's simplify it. 20 divided by 10 is 2. X to the 6th over x to the 2nd, we're subtracting, makes that x to the 4th. Y to the 2nd over y to the 3rd. You have a couple different ways to do that. That is y to the -1. So since that's y to the -1, when you do 2 minus 3, that means that y has to go in the denominator. Or I think of it as like this. I think of it as like there's 2 y's on top, there's 3 on the bottom, 2 cancel out, and I'm left with 1 on the bottom. So multiple ways to think about that, whatever is easiest for you, okay? So this one right here, we have our a's, so we're gonna do 4 minus 2, which is 2. Now, this b to the 0 is the same as 1, or sorry, yes, is the same as 1, or you can do b to the 0 minus -7, okay? Because we're minus -7, we subtract our exponents, that actually becomes a positive, okay? And then let's do the same thing with the c's. So -3 minus 1, okay, because there's an understood 1 right here, -3 minus 1. Now, that's going to become a squared, b to the 7th, c to the -4. But since we never have negative exponents, everyone has to be positive. So a squared, b to the 7th, -4 is on top. We got to pop it on the bottom and make it positive, okay? There's other ways you can do this too. You can cross this out and make this a 1, pop this to the top, make that b to the 7th, c to the -3, pop that to the bottom, and add your exponents. So many ways to do this, whatever is easiest for you. Okay, all right, so this one right here, we're going to, let's do each piece individually. So this 5 has to get distributed to everything inside. So that becomes a to the 10th, we're multiplying, all over b to the 15th, times, okay, multiplying, this is an understood 1, b to the 2nd, times a to the 10th, okay? Now here's what I think about this, okay? This is a to the 10th and a to the 10th. If you have the same thing on top and bottom, they're just gonna cancel. I also think of this as I have 2 b's on top and 15 on the bottom. Both of the b's on top are gonna cancel, and you're gonna be left with a total of 13 b's on the bottom. Or you can subtract and make this -13 and then pop it to the bottom. Whatever works, it doesn't matter, whatever is easiest for you. Okay, this one right here. So first, let's simplify the numerator. Okay, so we're gonna multiply the 4 to every exponent inside your parentheses. So this becomes a to the 12th, b to the 12th. Let's do the same. Now, you have a couple choices here. You can either distribute this inside of here first, or you can move the entire thing to the top and make just the 3 negative. Or sorry, just the 3 positive. It doesn't matter. There's so many ways to do this. So if you did a different way, totally fine. So this becomes a to the negative 3, because this is an understood exponent of 1. This becomes b to the positive 6. Okay. All right. Now to simplify this, we have 12 minus a negative 3, subtracting your exponents. So that becomes a to the 15th. 12 minus 6 becomes b to the 6th, and we're actually left with nothing in the denominator. Okay? Okay, so let's take a look at this one right here. I would simplify this portion first to make this is a negative in the denominator. Let's pop it to the top to make it 3 times 2 to the 2nd. Okay, this 1 over 2. So if we want to simplify this, this would become 1 over 1 squared all over 2 squared. Okay, so now to simplify, we can do 3 times 2 squared times the 1 is in the numerator and the 2 squared is in the denominator. Now, if you notice here, we have a 2 squared on top and 2 squared on the bottom. They actually cancel each other out, and 3 times 1 is just 3. Okay, all right, so this one right here, multiple ways to do this. Once again, there is nothing with the y's. I lied, there is something with the y. So let's simplify this first. So we have y z to the negative 2. Make sure you distribute that 3 to every exponent inside. So that becomes x to the 6th, y to the 3rd, z. Okay. So this y and this y are the same. So 3 plus 1 gives me y to the 4th. I'm just going to cross those out because I'm done with that. X to the 6th. Okay, done with that. Z to the negative 2. This is an understood 1. So this would be z to the negative 1. Now, remember, we can't have any negative exponents. So y to the 4th and x to the 6th are happy where they are. Z to the negative 1 is on top. So we got to pop it to the bottom and make it positive. All right, if you have any questions, please reach out.